There are millions of container movements annually worldwide. 40% are packed from top to bottom with one and the same product. Unloading these floor-loaded containers costs time and money. Because the containers are loaded with pallets, they can only be unloaded manually. This involves a lot of labor to unload the boxes or bag from container and make them ready for the transshipment or storage. This system works, but if you regularly deal with unloading containers, then you are aware of the bottlenecks this process. Your employees have to do a heavy and ergonomical, irresponsible job by manually unloading the goods from the container and processing it. You expose your employees to physical risk and your company to potential sickness and reintegration cost. Damage or the disappearance of the good is a real threat. Mistakes can be made in processing the load. What's more, unloading containers costs a lot of time and money. Hi, my name is Kumar Ashu. I am a third-year student pursuing Electronics and Communication Engineering. Being a CLAT certified and a CLD trainee, my main job in the team was to build LabVIEW applications.
Hi, my name is Rahul Gautam, a third-year student pursuing Electronics and Communication Engineering. My role in the team is to design and fabricate electronic circuit boards and support my team in electrical and electronics domain.
Hi, my name is Shiv Chaudhary. I am doing electrical and electronics engineering. My main job in the team is to interface third-party sensors with the LabVIEW application.
Hi, my name is Rishabh Kanodia. I am a third-year BTech student pursuing electrical and electronics engineering. Being a CLAT certified, my role is to develop LabVIEW application and help designing the circuits.
Hi, my name is Sharad Gupta. I am pursuing mechanical engineering. My role in the team is to design and fabricate the different parts of AGP.
Hi everyone. Now this is a brief description of the design of our AGP robot. And this is the main screen of the CAD software called SolidWorks. So it is the basic CAD model of the design. Actually it is the assembly view and all parts list can be seen here in the feature tree. The basic reason to create the CAD design was to make a proper model which can fulfill all the tasks and easily manufactured, because by the software the dimension and sizes can be achieved. So this model works as a reference. So here I take this ground as a reference and all the aluminum profiles I use for the basic structure because it can be assembled easily. Now you can see all the aluminum profiles here. And these are the aluminum angles which are basically used with these type of profiles to attach and deattach. And for the ASRS, the wooden sheets are used because these are cheap, easily available and lightweight. To make it very comfortable and easy, the electromagnets are attached with it. So when the RFID reader gives a signal for the correct bin, it actuates the electromagnet and the bin gets stuck with the electromagnet. Here you can see the electromagnets which are fastened with the wooden fork. And for the motion transmission, the mechanism wheels are used in the 4-linkage motion train because this type of train gives the stability for the system. That's why 4-linkage motion train is used here. Due to the movement in all the 6 directions, especially mechanism wheels are used. Basically these shown wheels are normal wheels because the design of the mechanism is very difficult. So the wheels which are shown here works only as a reference. So this is the animation of ASRS. First our AGB moves towards the desired bin, and then RFID reader gives the signal to the electromagnet to actuate it. And after it, the bin gets stuck with the electromagnet, and by this, the ASRS takes place.
Dealing with electronic circuits wasn't an easy task.
the major challenge we faced was to design supplies for various rating hardware components and make the system as stable and safe as much as possible. In the beginning, the motor drivers behaved a bit ambiguous. It took a while to understand them fully. Moreover, the output from the sensors were also needed to be manipulated to logic 1 and 0 form. Step in the electronic circuits is the power supply and the protection circuit. The power supply circuit is having various voltage regulators and filter sections. For protection from overcurrent, we have used fuses of appropriate values. Also, the reverse current from the motors was dangerous for delicate electronic components. For that, we have used flyback diodes. This is our current monitoring setup. The setup is having ACS 712 current monitoring module. The output from the sensors is processed in NIY101. These are our motors. We have used 12 Newton meter BLDC worm geared motors. The operating voltage across each phase of these motors is about 12 volts. We have used these motors because these are the only motors we could find in India having worm gears and appropriate torque. This is our main processing unit, NIY101. We have used port A and port B for the PWM outputs for the motor drives. And we have used port C for logic input outputs, current sensor values and controlling the directions of motor.
From this video, I want to show the working of an ACS sensor. An ACS sensor is a device which measures the amount of current flowing through it using the concept of Hall effect to detect the magnitude of current. In the current video, we are showing you the single wheel motion without any load. Corresponding to the motion of the wheels, a chart is shown which displays the readings from the sensors of particular wheels. When we apply load to the wheels, the respective current sensor value goes high. Now as you can see, when we are applying force on the wheel, the current sensor value represented in green color goes high from its normal fluctuations. Notice that the reference current value, which was earlier 3.2, has been changed to 2.9, shown in the dotted red line. When any of the current sensor value crosses this limit, the system immediately shuts down.
RFID, or radio frequency identification, is the wireless use of the electromagnetic fields to transfer data. We have used the RFID sensor to distinguish between different pallets. Our AGV communicates effortlessly via RFID tags to the pallets. It forms an indigenous system which guarantees that the AGV has detected the goods and faultlessly removes them from the shelf. This is our ultrasonic sensor from Pepperland Fergs used for obstacle detection. This sensor allows us to set two detectable ranges which can be teased manually, which correspond to A1 and A2 mode. It has a dead zone of 20 cm from sensor in which it is irresponsive. We have teased A1 mode to 3 meter and A2 mode to 1 meter. So whenever an object comes in front of an AGV in 3 meter range, it starts to slow down, and when the distance becomes 1 meter or less, the AGV comes to a halt. This is our guiding system. This is a data metric based position tracking system for automated guided vehicles. The PosiTrack PGV or PGV stands for Position Guided Vision. Traditionally, AGV control is accomplished by typically a magnetic segment or embedded magnets in the plant floor, or maybe optical system with reflectors or system that use a contrasting tape or paint that might be on the floor. These type of system also require an RFID tag embedded in the floor to start and stop something, or to initiate a turn, or to encode to jog a AGV forwards and backwards. The beauty of this PGV is that it combines three of these technologies in single unit. You get your tracking, your positioning, your start and stop, or your initiation all in one product. It is a 2D scanner camera. This camera will provide a 0.2 mm of resolution and a view field of 120 mm. It has a stand distance of 100 mm.
It is the final PGV code block diagram. This code has been built strictly according to the NI style guidelines. Here is a final code that we have built for PGV sensor interface and its data interpretation. We have extracted here all the relevant information which is needed to guide a vehicle.
Everything owes its existence solely and completely to sound.